notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. These first 3 sections, all 51 videos, have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 6, algebra. We are now here at video 10 of 22 videos, and hopefully by mid-September, this section will be done. Section 7, relations, functions, and graphs, by the end of October. Section 8, geometry and trigonometry, by the end of November 2025. And finally, Section 9, vectors and matrices, by the end of December 2025. That's by the end of this year. Disclaimer: this schedule is just a projection, and it is not to be interpreted as a contract with anybody. Section 1, number theory and computation. As I just pointed out, all 33 videos from this section have been published on YouTube in their entirety, especially in the light that this section, that is section 1, forms the foundation on which the rest of the syllabus is based. So please make sure you look at these 33 videos and know them very well. A reminder that you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Continuing, section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, measurement. These indicated by yellow here have been published on YouTube in their entirety, and the others are only partially published. Please see direction in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics. 18, these 5 indicated by yellow here are published on YouTube in their entirety, and these others only partially published. Again, please see direction in the description below to get full access to these videos that are only partially published on YouTube. So we are now at section 6, algebra, and this section has 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends the following, shown at right, these here. From those, please pay close attention to these last 2, as they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, mathematics, a complete course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Another disclaimer: I get no financial or other benefits from the sale of these books. Also, very recently, I think late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. You can navigate that website by topics or years, where all questions for the past several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page looks like for RSC. And this is what the home page looks like. You will first have to register, and subsequent to that, sign in. Again, this is the URL up here. This URL will be in the description of this video below, so you can easily click on it and you will be redirected to this website. Another reminder, this formula sheet is provided for CSEC math examination papers. There will be a link in the description below from where this formula sheet can be downloaded. This formula sheet you see here on the left. Of course, if you have a full copy of the syllabus, this formula sheet can be found in that syllabus. To take a closer look, this is the top part of that formula sheet. Note, you do not need to learn these formulae, as this formula sheet will be provided during the math examinations. And this is the below part of that same formula sheet. But you do need to know when and how to use these formulae, even if you don't have to memorize them. Overview of section 6, algebra. These first 4 objectives you see here have been completed in these first 4 videos there. More overview of 3 more objectives, and all 3 of those from 5 to 7 have been completed in videos 5 to video 7. Continuing with overview, so far from this page, objectives 8 and 9 have been completed in videos 8 and 9, which means that we are now at objective 10, this objective here, and we are doing that in video 10, entitled Linear Equations with One Unknown, video 10. After that, we have 5 more objectives on this page that we will work on from video 12 to video 17. And then finally, the last 5 objectives from this section, end of section 6, algebra. We will complete those objectives in these last 5 videos, which will take us to video 22. So we continue here. Objective 9 in video 9, law of indices. That was the last objective we did. These 3 indicated in yellow here have been published on YouTube in their entirety. These others only partially published. Right now, I am working on objective 10, which is video 10. Once I finish with this, it will be published in its entirety on YouTube. So objective 10, solve linear equations in one unknown. In objectives 1 and 2 of this section, we learned how to formulate algebraic expressions using symbols. At that stage, we were not required to solve those algebraic equations, though we did solve some examples that I gave then. Now, This objective specifically states that we need to solve linear equations in one unknown. Just to refresh your memory, when we did objective 6.1, I introduced you to the concept of forming equations and solving them with this example. I think of a number. I multiply it by 3, then I subtract 2, and my answer is 10. What number did I think of? So first of all, we will let the number be a, represent the unknown by a symbol. Then we will convert the word problem into an equation. So a is multiplied by 3, and from that, 2 is subtracted, and we get 10. So that is the equation. A multiplied by 3 minus 2 is equal to 10. Then we solve it. I already explained how to solve it. Essentially, you do the same things on both sides of the equal sign so that only the symbol remains on the left-hand side. So we have a negative 2 here. We add 2 on the left-hand side, and we add 2 on the right-hand side. And that will get rid of the 2 from the left-hand side. And the negative 2 on the left-hand side now become positive 2 on the right-hand side. And then we divide this left-hand side by 3, and we divide this right-hand side by 3. And once we do that, we get a is equal to 4. So the number I thought of was 4. We can easily check to see if this answer is correct. I multiply 4 by 3, and then I subtract 2. Do I get 10? And the answer is yes, which means that 4 is the number I thought of. Just to refresh your memory, this was example 2 that I introduced you to in the very first video in this section. Charlie was sitting on a bench in the park when he noticed a group of his fellow students walk by. He shouted out to them, "Hey, you 100 students, where are you off to?" One of them replied, "We are not 100. It takes twice as many, plus half as many, plus quarter as many, plus you to make 100. How many students were walking by?" Now, one not so good method we can use to solve this problem is to guess several numbers. I'm not going through this again. I already explained this in the video 1, and we found out that 36 would work because we get twice as many, plus half as many, plus quarter as many, plus 1, and that would make 100. But that's guessing, and it's not a very good method. We know a very good systematic method to work that question. So we will let the unknown number be n, represented by a symbol. We will convert the word problem into an equation. So n multiplied by 2, that is 2n, twice as many, plus half as many, plus quarter as many, plus 1 equal to 100. So now we have the equation. Now we have to solve the equation. I already solved this, so I'm going through this very quickly. You find an LCM, then you ignore the LCM, and you are left with 8n plus 2n plus n is equal to 396. You solve this equation, and you get n is equal to 36. So 36 students were walking past Charlie. We can test our answer. Twice as many, that's 2 times 36, plus half as many, half of 36, plus quarter as many, that's quarter of 36, plus 1, is that equal to 100? So 72 plus 18 plus 9 plus 1, is that equal to 100? And the answer is yes. So we know 36 students were walking by, working it out in a systematic way rather than guessing. Now back to this objective here in section 6, objective 10. Solve linear equations in one unknown. Note you don't have to form the equations. Now this objective states that we need to solve the linear equations with one unknown. So 2 things first. What is a linear equation? A linear equation is one in which all the indices of all the symbols are 1. For example, 2a to the first power plus 5 is equal to 3a to the first power minus 2. Notice the indices of the symbol are 1. Other equations may also have other indices like 3a squared. You do have a 5a to the first power here. Now, this particular type of equation here is called a quadratic equation. And that is not to be covered in this objective. We will deal with that in objective 16. So consider the equation that we did before. Number 1, I think of this number, and so on. And we solve. Now, notice this point here. You do the same thing on both sides of the equal sign so that finally only the symbol remains on the left-hand side equal to a certain number. And then we can easily check our answer. So if you look at this again, you represent the unknown by a symbol. Now, we don't have to do that in this objective. That has already been done for us. Convert the word problem to an equation. We don't have to do that in this objective. It just says solve linear equations. We already learned how to convert word problems into equations. So I am repeating, to solve this, you do the same thing on both sides of the equation. So this is a minus 2, negative 2. We add 2 on this side and we add 2 on that side. And that will get rid of this 2 on this side. And so we are left with a times 3 is equal to 10 plus 2, which is 12. Now we need to get rid of this times 3. We divide both sides by 3. That will get rid of the 3 over this side, meaning it would be reduced to 1. And we have 12 divided by 3. And we get a is equal to 4. Now that is the procedure that we have to learn and to use. It is not as difficult as some people make it out to be when they hear about solving equations. So go through this again. We do the same thing on both sides. We are trying to get only the final line. One of the symbol is equal to a single number. That is our goal. And to do that, we will add or subtract or multiply or divide so that the numbers only appear on one side and the symbol appears only on one side. So it says our objective at this stage is to ensure that the unknown symbol is on the left-hand side, just a symbol, and everything else appear on the right-hand side. That is our objective. And to accomplish that, I repeat, you do the same thing on both sides of the equation, one step at a time. The equation remains the same or unchanged if you do the same thing on both sides, called the balance method. Now, there is a shortcut that would give you the same result. So instead of adding a positive 2 on both sides, instead of dividing by 3 on both sides, there is a shortcut. So we will take this negative 2 and actually transfer it to the next side, but we'll have to change the negative to positive. And then we'll take that multiplied by 3 and carry it to the other side, but we'll have to change it to division. And so we get a is equal to 10 plus 2, all of that, divided by 3. Now this is a shortcut. You can do that if you like, but sometimes math teachers like to see the working. And so we get a is equal to 4. 10 plus 2 is 12, divided by 3 is 4. That's a shortcut. I will not use the shortcut here except for one, the last example. In every other case, I will follow the normal system of doing the same thing on both sides of the equation. So our objective is to ensure that the unknown symbol is on the left-hand side and everything else appear on the right-hand side. And as I said, to accomplish that, you do the same thing on both sides of the equation, one step at a time. The equation remains the same if you do the same thing on both sides. So let's look at this example. Solve for a. 12a minus 23 is equal to 25. So if we add 23 on this side and add 23 on that side, we will get rid of the 23 from this side. And in effect, we would have moved that negative 23 from the left-hand side and make it positive 23 on the right-hand side. So we get 12a is equal to 48. Now let's deal with this 12. 12 is multiplying that a. We will divide both sides by 12, and that 12 will reduce that 12 to 1, and so you get a is equal to 4. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. From here on, you will be given the equation. You will not have a word problem and then to form equations and then to solve, because we already did those in previous video. So now we are just going to solve given equations. So we use the same principle in all linear equations with one unknown. Our objective is to ensure that the unknown symbol is the only item left on the left-hand side and everything else appear on the right-hand side of the equation sign. And to accomplish that, you will do the same thing on both sides of the equation, one step at a time. The equation remains the same if you do the same thing on both sides. So our equation is this, example 3. Solve for a. 9a plus 4 is equal to 6a plus 10. So subtract a 4 from this side, and that will get rid of that 4. And let's also subtract a 4 from this side. So in effect, you have moved that plus 4 from the left-hand side to the right-hand side and made it a minus 4. We do the same thing for the 6a. There is a 6a over this side. We want to remove that 6a and carry it on the next side. So to remove it from this side on the right-hand side, we will subtract 6a. And of course, on the other side, we will also subtract 6a. So you have 9a minus 6a is 3a. That works out to 0. This works out to 0. 10 minus 4 is 6. Now you still have a 3 on this side that we want to get on the next side. What is 3 doing on the left-hand side? It is multiplying. So we will divide both sides by 3. So 3a divided by 3, that would reduce the 3 to 1a. And 6 divided by 3, this is what we get. A is equal to 2. So that is the general principle that we will apply in all such equations. Example 4, solve for b. 43 minus 2b is equal to 8 minus 9b. So we want to get rid of this 43 from this side and put it on the next side. So we'll subtract 43 here, and we will also subtract 43 here. In effect, you have moved that positive 43 to the right-hand side and made it negative. Let's look at the b's. There is a negative 2b here. It is already on the left-hand side. We are not going to move it. There is a negative 9b here. So we will add 9b on this side, and that will reduce this 9b to 0. And we would add 9b on the next side as well. So in effect, we have moved negative 9b from the right-hand side to the left-hand side and changed the sign to positive 9b. So negative 2b plus 9b is equal to 8 minus 43. That's what we have to this stage. When we work the left-hand side, we get 7b, positive 7b, is equal to negative 35. We divide both sides by 7, and we get b is equal to negative 5. So as I said, we use the same principle for all these equations. our objective is to ensure that the one unknown symbol is on the left-hand side and everything else appear on the right-hand side. So example 5, solve for d. 5 multiplied by d minus 2, close bracket, plus 3 multiplied by 2d plus 5 is equal to 4, open bracket, d minus 7. So we will remove the brackets by using the distributive law. So this is 5d minus 10, that is 5 multiplied by everything in there, plus 3 multiply everything in there, 6d plus 15 is equal to 4d minus 28. So we have a negative 10 here that we want to get rid of from the left-hand side, and we have a positive 15 that we want to get rid of from the left-hand side, and we have a positive 4d that we want to get rid of from the right-hand side. So this is what we'll do. That negative 10, we will add positive 10 on this side, and we will do the same thing on this side. This positive 15, we will include negative 15 on the left-hand side and do that on the right-hand side as well. In effect, we have moved the positive 15 from the left-hand side to the right-hand side and made it negative. And then this 4d here, positive 4d, we will subtract 4d from the right-hand side, and we will also have to subtract 4d from the left-hand side. And so what we get is 5d plus 6d minus 4d, 5d plus 6d minus 4d, that's on the left-hand side, and negative 28, we didn't move that, that is still there, but now you have a positive 10, which is this, and a negative 15, which is that. So 5d plus 6d is 11d minus 4d is 7d, and 28, negative 28 plus 10, which would give you negative 18, minus 15, which would give us negative 33. So now we divide both sides by 7. That 7 will reduce that 7, and then over this side, 33 divided by 7, and we get d is equal to negative 4.71. Example 6, solve for v. 4v over 7 minus 5 is equal to 1 minus 3v over 14. So we will find our LCM, which is 14. 7 into 14 is 2, and we take that 2 and multiply this 4v up there, that is this, minus, remember that's a 5 over 1. So 1 into 14 is 14, 14 multiplied by 5, that's this, equal to, again that's 1 over 1, so 1 into 14 is 14 times 1, and then minus 14 into 14 is 1 times 3v. Now that we have everything on the same denominator, we can forget this denominator and only concentrate on what is on the top there. Yes, now that we have everything in the equation on the same base, LCM, we can discard that LCM. And so all that we have now is this. We have gotten rid of the fractions. So this will work out to 8v minus 14 times 5, 70, equal to 14 ones 14 minus 3 ones 3v. We will try to get that 3v on that side and this 70 on the right-hand side. So 8v minus 70, we plus 70 here on this side, so we will get rid of that 70, and we plus 70 on this side as well. Next thing we will do, we would add 3v on both sides, so we will get rid of that 3v on this side, And this is what we are left with. 8v plus 3v is equal to 14 plus 70. So 8v and 3v is 11v. That will be equal to 84. Let's divide both sides by 11. And so this will work out to 1. And v actually works out to 7.63636363. That is what these two dots up here mean. Example 7. Let's revisit that question with the 100 students. You know how that goes already. So we were able to form this equation. This objective says, given that equation, how will you solve it? Well, the first thing we did here is that we subtracted 1 from both sides to get rid of this one here. And so we are left with 2n plus half n plus quarter n is equal to 99. You can use an LCM and you get 8n plus 2n plus n is equal to 396. Now that everything in the equation, they are on the same base, the LCM, we can discard the LCM, can discard this. And we are left with 8n plus 2n plus n is equal to 396. On the left-hand side, we have 11n is equal to 396 on the right-hand side. If we divide both sides by 11, that will reduce that 11 to 1. And we can work this side out, and we get n is equal to 36. So the answer is 36 students were walking past Charlie. Below are some other equations that you can try on your own. They're basically the same type of equation. That's 1, 2, 3. They're basically the same thing. You work them all the same way. 4, 5, and 3 are basically the same question. And then example 6, 7, 8, 9. Now, I will do one of these for you. As a matter of fact, equation 3, I will do that one. But keep in mind that that one and this one here, they are the same. And these are the answers down here if you take the time to work them out. On the next slide, I will do equation 3, and we will see that we get 5.1. So as I said, I'll do this one. 2x plus 1 over 8 is equal to 7 over 5. We find the LCM, 8 and 5 would be 40. 8 into 40 would be 5, so we multiply that 5 by everything in here, equal to 5 into 40, 8 times 7. Now, as I said, we can remove that over 40 because everything above, they are now on the same base, the same level, the same playing field. So we have 10x plus 5 is equal to 56. Now, I am doing the shortcut here, so I'll do everything one time. I take that positive 5, carry it over the next side, and I get negative 5. And I take this 10 that is multiplying on the left-hand side and carry it on this side and divide. So I'm actually doing the shortcut. If you do it the long way, you will still get the same answer. And so x is equal to 56 minus 5, which is 51, divided by 10, which is 5.1. And that should suffice for this objective, where you had to solve linear equations in one unknown. Now, in the next objective, objective 11, we will also solve linear equations in 2 unknowns. But then we would have to get 2 equations, not 1. So in the next objective, we will learn to solve simultaneous linear equations with 2 unknowns. So we will continue to apply these principles that we just learned in this video. Objective 10, section 6, solve linear equations in 1 unknown. And that brings us to the end of video 10, based on objective 10 in section 6.